let's look at this problem right here. Okay, so something I see about this first off is that every one of them has a y, so I can factor out a y. Then I need to see if I can factor any of those numbers. So, see if 18 has anything in common with these. This is an even, so 2 wouldn't work. Let's see about 3. 87 divided by 3. Yes. 126 divided by 3. So it looks like each one of these is divisible by 3 and y. So going to factor out the 3y, and 18 divided by 3 is 6. So 6, and keep my x squared. 87 divided by 3 is 29, so plus 29x minus 126 divided by 3 is the 42. Okay, so far that's what we can do. So the next thing would be to see if we can factor the trinomial. So remember AC, A is 6, B is 29, C is 42. So up top, you're looking at the product of AC. So we would multiply 6 times 42 to get 252. And then B goes down here with the sum. So we're looking for a product of the 252 with a sum of 29. So let's see, 252 divided by 2. So 126 times 2. But if I add those, it's not going to work. Oh, this would be a negative, by the way. Product of a negative. So one of them would have to be negative. So let's say I do that. Well, that's not going to work anyway. 252 divided by 3. 84 and 3. And because the sum is positive, but the product is negative, I know that my larger factor is going to be my positive. So let's do 252 divided by 4. 252 divided by 4 would be 63 times 4. So if I add those, it doesn't give me 29, so let's keep on going. I know 5 won't work, so let's do 252 divided by 6. 42 and 6. If I do 42 minus 6, gives me 36. I'm getting closer. 252 divided by 7. 36 times 7. And remember, the positive one's going to be here, so times a negative. So if I do 36 plus a negative 7, that gives me the 29 that I need. So it's 36 and negative 7. So 36 and negative 7. So whenever I do my box, top is ax squared, bottom is the negative 42, and then these two go here with x's. Okay, so then we're going to factor the column, factor the rows. 6x squared, we'd have 6x, and then negative 7x minus 42. The leading one is negative, so it's going to be a negative, and 7 will evenly divide 42, so I know it's 7. Here, they don't have anything in common except for x. Here, click a 6 would work. And you can double check yourself by doing x squared times x is 6x squared. Negative 7 times x is negative 7x. 6x times 6 is 36x. And negative 7 times positive 6 is negative 42. So that works. So our factor is going to be 3y because you got to carry this down. And then your binomials. 6x minus 7 and x plus 6. And you can always multiply those out to make sure you did it correctly. So it takes a little bit of time. All right, this says factor the difference of two squares. This is 16x squared minus 9. So this has 16x squared plus 0x minus 9. So you could do the x box, or you could use the whole difference of squares. There is a kind of like a format for that. But I'll show you this. A is 16, B is 0, and C is negative 9. So A times C, so 16 times 9. Well, yeah, negative. So it'd be negative 144 with a sum of 0. So we want the product of negative 144 with a sum of 0. So that would be 12 and negative 12. Because if you add those, you get 0. So 12 and negative 12. So this is 16x squared. This is minus 9. This is negative 12x. And this is positive 12x. So when you factor, a 4 will go into both of those. When you factor here, the leading one is negative, so it'll be a negative. 12 and 9 have a factor of 3. And then this direction is the same, 4x, and a plus 3. So it's 4x minus 3, 4x plus 3. There is, let's see, the difference of squares is this formula. A squared minus b squared equals a plus b, a minus b. So it's called difference of squares because there's a subtraction. So if I use this to do my difference of squares, this is 16x squared minus 9. Well, as a squared, if I take the square root, that'd be 4x squared, because 4 times 4 is 16, x times x is x squared, minus 3 squared. So once I figure out what the squares are, then I can say my a is 4x and my b is 3. So I write it in this formula, a plus b times a minus b. So it'd be 4x plus 3, 4x minus 3. See how it's the same thing? So if you know that's a difference of squares, you can use this format to factor it. So this is another difference of squares. So it's x cubed minus 81. No, x to the 6. Right? So I know this is 9 squared, right? This would be anything squared will be x. And whenever you have exponents, like a power to a power, see how there would be a power here to a power, you multiply them. So I would say what times 2 is going to give me 6, and that's 3. So that means that my a is x cubed and my b is 9. So I can write this as, remember, a minus b, or a plus b times a plus b. You have the same thing, just one's positive and one's negative. So this will be x cubed plus 9, and this will be x cubed minus 9. The next one says factor the difference of the two squares again, minus the 256. And so the way you know it's a difference of two squares is if this is a perfect square. So you can take the square root of 256. It's 16. So you'd want to do the same thing here. So what times 2 is going to give me 4? And that would mean it's 2. So then I'm going to do the a plus b, a minus b. So it's going to be x squared minus 16, x squared plus 16. Okay, and the thing about this is another difference of squares. So we've got to do it again. So this could be written as x squared minus 16 is perfect square, 4 squared. We're not going to do anything with this. We're going to actually carry it down once we factor. So this is going to be x minus 4, x plus 4, and then x squared plus 16. And the reason we can't factor this is because it's plus, it's the sum of squares instead of the difference of squares. So this would be our solution. Find the least common denominator. So we have 7 over 20x to the 4 and 1 over 12x. So least common denominator is the greatest common multiple. So with your x's, you take the smallest, your GCD, which is also called your LCD, greatest common denominator, least common denominator, least common multiple, I think. Anyway, it's LCD. So with the variables, you take the least, so it'll be x. And then you look and see, what are my multiples of 20? It'll be 20, 40, 60, 80, and so on. Multiples of 12 are 12 times 2 is 24. 12 times 3 is 36. Keep on going up by 12s, 60, until you find a match. You want the least. So 60x is going to be my LCD. See? So 60x. So there's another part. Let's see. Let me see what I messed up on. That would be like, let me pause this. I know what I did. I didn't put in the x before. So you actually take your largest, because you want to be able to multiply this by something to get the same thing. You can't divide it. So instead you're going to multiply it. So it should have been x to the 4th. So I messed up. So if you look at this one, this has the same 20 and 12, which is 60. But then you take your largest exponent, so it's x squared. So let's look at this next one. Question 28. 15 over x minus 4 and 16 over x squared minus 16. So this is a difference of squares. So this will be x plus 4 times x minus 4. So this already has the x minus 4. So our GCF, or our least LCD, is going to be x plus 4 and x minus 4. Okay, multiply and simplify by factoring. Okay, So what you can do is you can actually multiply these. 150. And so if you want to simplify, we want to type as a radical. So we want to look for any perfect squares that evenly divide this. So we would think back to our perfect squares. So like 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Oh, sorry. 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. So this is the start. So we're going to see if any one of these divides it evenly. And 25 does. So we're going to rewrite this as the product of a perfect square and something else. It'd be 25 times 6. Then you can break it up into square root of 25 times square root of 6. The square root of 6 is 5. So it'd be 5 square root of 6. And that's as simplified as we can go because none of these perfect squares will evenly divide 6. So we'll look at the next one. Square root of 5x times square root of 20x. So go ahead and multiply them. 5 times 20 is 100. X times x is x squared. Keep your radical. 100 is a perfect square, but so is x squared. So square root of 100 is 10. Square root of x squared, if I take the square root of x squared and square roots cancel each other, so that just leaves me with x. So what this means is 10x squared is 10 squared is 100. X squared is x squared. So then it's 10x is the factor of this because the square root of 100 is 10. Square root of x squared is x. Once you take the radical out, you don't need it on here anymore. Let's see. Add as indicated. So in order to add, you have to have a like radical. Just like terms, you have to have the same variable. So square root of 8 plus square root of 50. We cannot just add these. You got to simplify this radical. So you look for a perfect square that can evenly divide, and 4 will. So this will be square root of 4 times 2. Square root of 4 is 2, so it's 2 square roots of 2. Then this other one, perfect square that evenly divides 50 is 25, so square root of 25 times 2 is 50. So plus square root of 25 is 5, square root of 2. So now we have like radicals, just like when we have like terms. So we just add our coefficient. So 7 square roots of 2 plus 5 square roots of 2 makes it, 2 square roots of 2 and 5 square roots of 2 makes it 7 square roots of 2. Okay. So we have to do the same thing on this one. 3x minus 7, 28x. We gotta look and see what perfect square lies inside of that. And 9 is inside there. I think that's the only one. 28. We'll evenly divide 28. I think it's 4. So let's do that one first. 4 times 7. And see how I did it this way, but also did it this way? They're the same. I just separate them out. Square root of 2, or square root of 4 is 2. So it'd be 7 times 2, square root of 7. 7 times 2 is 14. So 14 square roots of 7. Okay, so we simplified that one first. So if I want to be able to combine these, I need them to have both 7s. So this is 7 And then this would be 9. Oh, there's an x here too. X can't be taken out. 9 times square root of 7. So square root of 7 is 3. So 7 times 3, square root of 7. Forgot my x again. So then we have like terms because we have like radicals. And so we just combine these. So 21 minus 14 is 7. So 7 square roots of 7x. Okay, you're going to do the same thing here. Okay, whenever you write it as a half, that's the same thing as writing it as a radical. So 16 to the 1/2 is like this. You put the denominator out front, and then this is your exponent. So this, since we have to the first power and it's squared, it's just square root of 16, which gives us 4. So anything to the 1/2 is really just taking the square root of it. To the 1/3 is taking the cube root. So negative 64 to the 1/3. The negative's out front. So it's going to be cube root of 64 to the first power, or just 64. So the cube root means what times itself gives us 64. We don't care about that one. So that would be just carry down the negative each time, because if it was parentheses, then the negative would go inside, but it's not. So this would be negative 4. So let's make sure. In your calculator, you go to math, and they have the cube root. 64. 4. Or you can do 64 raised to the 1/3. That's 4 as well. So it's under math, or you can do raised to a fraction power. Okay, the union of sets means them together. U means union. All together. So that means I'm going to write all of them. And you don't have to repeat them though. So 4, 6, 7, 8, 9. I don't have to repeat the 8. Okay, so that's another one. Union. So you put them together. Don't repeat. The other way is called intersection. So that's what they have in common. So in common, or you could put both sets. Sets. In both sets. So what's in both sets? 5 is and 8 is. And then the last question is another intersect. It has to be in both sets. Okay, hopefully that helps you on chapter 1.